Hey guys, I'm Prachi Agarwal from Pranveer Singh Institute of Technology, Snackdown Online Qualifier, and also an Infosys certified software programmer. Welcome to our YouTube channel, Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn data structures and algorithms, then this is a one-stop destination for you. Every week we'll post CodeChef problems explanations, conceptual videos on various programming paradigms, and also conduct live problem solving sessions. But before we actually get started, here's a reminder to hit the subscribe button if you haven't yet already. Great. So now that you have subscribed, let's get started. Today we'll be solving the problem racing horses, which is an easy problem based on arrays and sorting. Here's the agenda for today. First, we'll understand the problem statement and its inputs, outputs, and constraint. And then we'll discuss what observations have we found from the problem statement. Then we'll discuss the concept on which this problem is based and how to solve this problem, the algorithm that will be used in solving this problem. And after that, we'll also code this problem live on the IDE so that you get an idea of how the code should be written. Okay, so this is the problem statement. It says the main problem statement starts from here. So let's read it from here. It says that there are n horses and the skill of horse I is represented by an integer si. And what we need to do that we need to pick two horses for the race such that the difference in their skill is minimum. So what does this mean? Let us see. It says that there are n number of horses and each horse has a skill. So suppose that the number of horses in the stable is 5. So what do we understand from this information? That there is horse 1, horse 2, horse 3, horse 4 and horse 5. The horse 1 has a skill 5, horse 2 has a skill 1, horse 3 has a skill 10, horse 4 with skill 14 and horse 5 with skill 8. And each horse has a different skill. So now that we know and consider this S that is given, it is like an array. So S of 1 is storing the skill of horse 1. S of 2 is storing the skill of horse 2. S of 3 is storing the skill of horse 3 and so on. Now, let us discuss what inputs, outputs and constraints are there in the problem and then we'll move on to discussing the main part, the concept part. So first we need the number of test cases. So the first line will be the number of test cases, single integer. The second line onwards, it will be the input for each test case. So each test case will have n, which is the number of horses, followed by in the next line the array of skills, which is a single spaced array in which all the skills of each horse will be given. And what will be the output? Output for each test case will be a single digit actually. It will be a single digit it will be a single number which contains the minimum difference. And please note that the test case limit is very less. It is only 10 test cases. It is only limited to 10 test cases. And also the number of horses minimum will be 2 and maximum will be 5,000. So now let us see. This is how the input has to be there. 1 is the test case, then 2, this represents the number of horses in the stable, and this, since the number of horses are 2, so we have two skills here, 8 and 3, and since there are only two skills, so the answer, the minimum difference, 8 minus 3, which is 5, so this will be our answer here. Now, what are the main observations that we have made out of this problem is that there are n number of horses. Each horse has a positive skill number, so it will never be negative. The skill number will always be positive. The minimum difference will be found between two horses only. So out of all the horses, no matter how many horses are given, the minimum difference will be between the two horses. And we don't need to worry about erroneous conditions, like say we worry that what if only one horse is given, one horse skill is given, then how will we calculate the difference? So that is not our worry at all. That is covered by the question. Okay, let's move forward. Now this first approach, when you see this problem, the first approach that will come to your mind is that we need to calculate the difference, right? So from 5, if we calculate the difference of 1, 10, 14, 8, so we'll get the difference of 5 with every other number. Just like this. Like 5 minus 1 is 4, 5 minus 10 is 5, and 5 minus 10 is actually minus 5. But why have we not written minus 5 here? Because we need the absolute difference. So we'll remove the sign 10 minus 5 and 5 minus 10. We'll keep the difference positive always. Okay, now next you need to calculate the difference of 1 with every other number. So the difference of 1 with 5 is already calculated here. See, the difference of 1 with 5 is already calculated here. So the leftovers are 10, 14 and 8. So we'll do that. Calculate the difference of 1 with every other left out number. Now same thing we'll do for every other number. Like for 10 we'll calculate the difference of it with 14 and 8. For 14 with only 8. So from all these are all the differences. These all that you see written in red, these are the differences between any two horses. So what are we doing here? Here we are calculating the difference between the skill of any two horses that are there in the stable. So we found that from all these skills, the minimum skill is 2. So this is our answer. But this is a brute force approach. What is a brute force approach? That we take every possibility into consideration and then we solve the question. But is there a better solution to it, and what are the problems to this? So guys, now what is the problem with the brute force approach? The first problem is that there are too many comparisons. Like in the previous example, the number of horses were 5. So how many comparisons in total were we doing for it? The first number of comparisons were 4. That is, with the first number we were calculating the difference with the other 4 numbers. Then 3. With the second number we calculated the difference with the leftover 3 numbers. Then 2 and then 1. So a total of, if we add these comparisons, it will give us a total of 10 comparisons. Now if we calculate the general term for these number of comparisons, then it is coming out to be n into n minus 1 by 2. So now just imagine, if n were to be 1 lakh, then the number of comparisons would be too many. If it will be 1 lakh, number of comparisons would be huge. And what will be our time complexity? Well, our time complexity for this approach will be approximately n square, order of n square. So now for n square will never be accepted for a limit of 1 lakh. But since in this question, the constraint given for n is only 5000. The upper limit is just 5000. So probably for this question you might get an AC. That is an accepted answer if you use this brute force approach. But the point here is that we need to identify if there is a better solution to this problem. Well, there definitely exists an optimal solution, and now we'll discuss that. So now we have taken the same example that we were using earlier, but now what have we done in this? We have sorted this using a non-decreasing order. First, let's discuss that what is a non-decreasing order. Suppose you have the numbers 4, 3, 2 and 2. So what will be the sorted order, that is the non-decreasing order for this sequence? It will be 2, 2 and 3, 4. So basically non-decreasing order is just like ascending order, that is from small to big. We call it non-decreasing because if suppose there are repeated numbers in the sequence, then it does not uh, fit into calling it ascending order. So we call it non-decreasing order. Now, why have we done this sorting here? Now let us understand this. Earlier what we were doing, that we were comparing each and every like 1 was compared with 5 and we calculated the difference of 5 minus 1. Then 1 was compared with 8. So basically what we were doing, we were taking every pair of horses, each pair, we were taking each pair of horse and we were calculating the difference in their skills. But now just think about this. If our sequence is 1 is less than equal to 5, 5 is less than equal to 8, 8 is less than equal to 10, and 10 is less than equal to 14. This we can make out from this sorted order. This is the sorted order and this thing we can make out from this order. So what advantage have we got here? That 1 will always and always be less than 8. This is our biggest advantage. 1 will always be less than or equal to 10. 1 will always be less than or equal to 14. So we need to calculate the difference of only 1 and 5. And we do not need to calculate the difference of 1 and 8, 1 and 10, 1 and 14. Why? Because we already know that smallest difference will always be between 1 and 5. Means we need to calculate the difference of only adjacent numbers, that is 1 and 5, 5 and 8, 8 and 10, 10 and 14. So this is our greatest advantage if we just sort this sequence into a non-decreasing order. And now you already know that what is a non-decreasing order. So how will we calculate the difference? This is how. 5 minus 1, 4, 8 minus 5, 3, 10 minus 8, 2, 14 minus 10, 4. So this is how we are going to calculate the difference. And suppose if we had a repeated number like 5, 5 or 8, 8, if we had that, then also no problem. 8 minus 8 or 5 minus 5 would have been 0. So the skill difference between the horses would have been 0. And the lesser the better, so 0 would have been our answer. And so from this approach also we have found the minimum absolute difference, that is 2. And now talking about the time complexity of this approach, it will be order of n, that is linear time complexity. And order of n time complexity will always get an AC even if the upper limit was 1 lakh, as we discussed earlier. So guys, this is the best and optimal approach for this question. Now let us take another example to understand this better. In this also we have taken n equals to 4. So there are 4 horses and 4 skills. The skills are 4, 9, 1 and 13. Now what is the second step? We'll sort the skills in non-decreasing order. So we have sorted it. Now 1 is less than 4, 4 is less than 9, 9 is less than 13. Now what we need to do, just calculate the difference between the minimum skills. Just calculate the difference between the adjacent skills. That is what we need to do now. So see, we have calculated the difference between adjacent ones. 4 minus 1, 4 is adjacent to 1, so 4 minus 1, 3. 9 is adjacent to 4, so 9 minus 4. 13 is adjacent to 9, so 13 minus 9. And from all these, we have come to the conclusion that 3 is the minimum absolute difference. 3, 5, 4, which is minimum, 3 is minimum. So that is our answer. This 3 is our answer. Now let us see how we will go about the algorithm, and then you're good to go. The variables, first let's discuss what variables have we used in our algorithm, or what variables we'll be using in our code. So n is the number of horses. It is already given in the problem statement. Then this one, S, it is an array or a list with size n, and the skills of the horse I. It contains the skill of the horse, ith horse. It contains the skill of the ith horse. Now, I is the counter variable that we have taken, and minimum, it stores the minimum difference between any two horses. Now the algorithm. So first step will be to sort the array. First step will obviously be inputs, so that we'll do in the code, don't worry. But here the first step will be in the algorithm. It will be to sort the array that this array that we have taken as input. We'll sort this in non-decreasing order. Then this minimum, what are we doing? We are calculating the first set of difference and storing in minimum. S of 1 minus S of 0 means the skill of first horse minus the skill of the 0th horse. So the indexing basically begins from 0. So we are doing it this way, S1 minus S0. Actually 0 is the first horse and 1 will be the second horse. So the difference between the second horse skill and the first horse skill. After that, we'll run a loop from 1 to n. Why from 1 to n? Because the first set of difference between the adjacent skills have already been stored in minimum. So now we just need to compare with this minimum. If the difference already stored in minimum will be the minimum difference, then a minimum will not change, and if not, then we will check S of I minus S of I minus 1, that is S of 1 minus S of 0, S of 2 minus S of 1. So what are we doing? The present I minus the previous I. The present ith skill minus the previous ith skill. And if this difference is less than minimum, then what are we to do? We'll store this difference in minimum. We'll update minimum variable. And at last, when we come out of this for loop, we'll have our minimum absolute difference that we need as the output. So we'll directly print this. That's it, guys. This is the algorithm. And now let us learn how to code on the CodeChef IDE.
So guys, today I'll be coding in Python. In this problem, first we'll take the input for the test case. After taking input for the test case, we'll run a for loop from 0 to number of test cases. Obviously, we need to take input for each test case, so that is why we're running this loop. Then after that, we will take input for the number of horses. Now we'll take input for the skills. So the skills is given in the form of a string, which is a space separated list of numbers, sequence of numbers. So for that, here what we have done, map function will map each number to integer form, and split will split the space separated string into an array form. Now, after this, after all the inputs are done, the first step will be to sort the skills array. This will sort it into a non-decreasing order. After sorting, we'll define minimum variable. So minimum variable will be the difference between the skill of the second horse minus the skill of the first horse. After doing this, we'll run a loop for j is again the counter variable for this loop, and now the loop will run from 1 to less than n, that is the number of horses. Now we'll check if s of j, that is the present j, minus s of j minus 1 is less than minimum. Is it less than minimum? If yes, if we found that it is, then we'll update minimum with this statement. S of j minus S of j minus 1. This will be the minimum. And on repeating this process, we'll come to calculate the minimum absolute difference. And at last, what we need to do is simply print minimum. And that's it, guys. This is our code for this problem.
And now what we'll do is we'll submit this code to check if we have got the correct answer. So we'll submit it from here and let's see if it gets accepted. Well, fingers crossed. Hopefully it should get an AC. Well, see, this is the correct answer. And so we have done our part. And guys, also if you need to check the code with comments or understand it, then please